Today we're going to be talking about arithmetic sequences. So our learning goal, I will extend and graph arithmetic sequences I will write equations for arithmetic sequences, and I will solve real-life problems. So the first thing we have to talk about here is what a sequence is. And basically, a sequence is just a list of numbers that has a particular order to it. So if we were to look at, let's just find a basic sequence, something like this. This is a sequence of numbers. There's an order to it, there's something specific that's going on here, and so this is what we call a sequence. In this case, this is what we call an arithmetic sequence. That kind of looks like arithmetic. Remember, arithmetic is just adding and subtracting. So this is an arithmetic sequence because to go from one term to the next, all we're doing is adding 5. So if I had to come up with a rule for this sequence, my rule would be add 5. And another word for that adding 5, that would be what we call the common difference. So it is what every single term has in common. That's what the difference is between each term. So we call that the common difference. So each of these is called a term, and then our common difference is what we're adding or subtracting to get to the next term. So one of the first things that we have to figure out how to do is how to write the next couple of terms, which is basically as easy as it sounds. So if I gave you this sequence, 10, 7.5, 5, 2.5, ... Here's my sequence, or the beginning of my sequence, and I want you to write the next 3 terms. That means the next 3 numbers in this list. So what I have to do first is I have to figure out what is my common difference, or what am I doing to each term to get to the next. So to go from 10 to 7.5, I'm subtracting 2.5. So to go from here to here, I'm subtracting 2.5. So then what I want to look at next is, do I have the same difference between 7.5 and 5? If I take away 2.5 from 7.5, I do get 5. So sure enough, that is my common difference. 5 to 2.5 is taking away 2.5. So what I need to do then, I need to do this 3 more times to figure out what the next 3 terms would be. Something you can do here to organize it a little bit is to make a table with our position number and then what the actual term is worth. So what this means is the first number in my sequence is 10. The second number in my sequence is 7.5. The third number in my sequence is 5. The fourth number is 2.5. And then 5, 6, and 7, the next 3 numbers are the terms that I have to come up with on my own. So if I subtract 2.5 from 2.5, I get 0. If I subtract 2.5 from 0, I get negative 2.5. And if I subtract 2.5 from that, I get negative 5. So for every single change in term, I'm subtracting 2.5. And that goes all the way down. And I could keep going forever. There's no end to this sequence. So that's how we're going to write the next 3 terms of a sequence. For my second example, we're going to graph an arithmetic sequence, and we're going to look and see what we notice. So I'm told to graph 5, 4, 3, 2. The way that I'm going to do this is, again, I'm going to think about the position, So is the number first, second, third, whatever in line, and I'm going to look at the term value. The position I'm going to call n. The term I'm going to call a sub n. So when I have a little n like that, it's a subscript. So I'm calling this a sub n, and we'll talk about what that means a little bit more in a minute. What I need to look at is my position number. So my first number in line is 5. My second number in line is 4. My third is 3. My fourth is 2. So now, if I graph these, I can graph them, instead of using x and y, I can use n. So let's change that to an n, and this is a sub n. So I'm just looking at how these ordered pairs compare to each other. So I have 1, 5, 2, 4, 3, 3, and 4, 2. When I look at those points, what I notice is that they all lie on a line. Now, I'm not going to connect them because I can't have a position 1.5. You can't be the 1.5 person in line, right? So this is a discrete domain, and so that means I can't connect these. But I can see that these are all lined up on a line. That should make sense because remember, with an arithmetic sequence, the definition is that there's a common difference between my terms. So as my position is changing by 1, my term value is changing by a constant value. That's just a constant slope or a constant rate of change, which gives me a linear situation. What we are going to look at here is how we develop a formula for finding the nth term. So what that means is if I want you to find the 33rd term, instead of having to list every single number in that entire sequence, until you get to the 33rd term, we're going to have a formula where we can jump right to it. So let's start with a sequence that goes like this: 1, 3, 5, 7. So these are just my odd numbers, but this is an arithmetic sequence where my first term is 1, and I'm adding 2 every time after that. So this is adding 2, adding 2, adding 2, etc. So my first term is 1. So a sub 1 means my first term, it's 1. And my common difference here is 2, because that's what I'm adding every time. So we're going to make a table and just kind of look at how we can develop the formula from the table. So for position, what we mean is like what number in line. Another thing to call that would be n. So in my first position, we call that the first term. So my first position tells me my first term. Using numbers, my first term is just 1. Using a sub 1, or using my correct terminology, that first term is just a sub 1. I haven't done anything to the first term yet. My second number, or my second position, is a sub 2. Using numbers, that's just 3. It's 1 plus 2, which is going to give me 3. Using a sub 1 and d, then, I'm taking my first term and I'm adding d one time. For my third position, I call that term a sub 3. Using numbers, I take this 3, which was 1 plus 2, and I add 2 again, or 1 plus 2 times 2, and I get 5. So I took this first term, I took my second term and I added 2 to that and I got 5. Or if we look, I took my first term and I added 2 twice, or I added my common difference 2 times. For position 4, I call that a sub 4. Using numbers, I'm taking the term before, which is 1 plus 2 times 2, and I'm adding 2 more to that. Or you can see I have 2 times 2, and another 2 would be 3 times 2, and I'm getting 7. Or I'm taking my first term and I'm adding my common difference 3 times. And we should start to see a pattern here. For my second position, I added my common difference once. For my third position, my common difference got added twice. For my fourth, my common difference got added 3 times. Or I'm adding my common difference 1 less than the position number that I'm on. So if I wanted to summarize that, for position n, I call that a sub n. That's my nth term. What I would be doing is I take, like in this case, I'd be taking my first term and I'm adding n minus 1 times 2. Because look, if I wanted my fourth term, I added 2 3 times. So if I want my nth term, I add 2 n minus 1 times. Or using my a sub 1 and d, remember this is my first term plus n minus 1 times my common difference. So this right here is the formula that I'm going to use to jump to any term that I want. So for example, if I wanted the 30th term in this sequence, so say I want position 30, that's my a sub 30 term. So what I'm going to do is I'm going to take this formula, I'm going to put in my first term, which was 1. Here, let's write the formula out. A sub n, so my nth term equals my first term plus the position minus 1 times my common difference. I want the 30th term, so I'm going to put in a sub 30. That's going to equal my first term, which was 1, plus my position number minus 1. So 30 minus 1 times my common difference, which was 2. Or this would be 29 times 2. So my 30th term is going to be 1 plus 58, or my 30th term will be 59. That means if I went back up here and that's my first term, second term, third term, fourth term, if I listed 30 numbers, the 30th number would be 59. So it was a lot faster to use this formula than it was to just keep listing all of my odd numbers all the way out to 30 of them. So this formula right here is the one that you're going to want to remember. Your nth term is your first term plus the position number minus 1 times your common difference. So this is the key. Let's do one more example using that. So if we had this list of numbers, or this sequence, 96, 92, 88, 84, etc. And I want to know just a specific term in this list that's not easy to just count down to. I'm going to use my formula. That was a sub n equals a sub 1 plus n minus 1 times d. My nth term equals my first term plus the position minus 1 times the common difference. What I want to do first is let's come up with an equation for the nth term that's a little more simplified to this specific situation. So in this specific situation, my common difference is subtracting 4, or negative 4, because every time I'm taking 4 off. The other thing, so I can substitute that in for d, that's going to be negative 4. The other thing I can substitute is my first term. My first term is 96. So in order to come up with a more general formula for this situation, let's just substitute what we know. I'm still going to be using this formula to find my nth term, but that's going to equal 96 plus n minus 1, or my position number minus 1, times my common difference of -4. So what I'm doing is I'm going to come up with a simpler formula for this specific situation, and then I could use it to find, like let's say I wanted to find the 14th term, the 20th term, and the 39th term. If I come up with a simpler version, then it won't be quite so challenging just to solve for those 3 terms. So what I need to do here is I need to just simplify this. Distribute that -4 through. So this is 96 plus -4n minus a -4, or 96 plus -4n plus 4. Now I see that I have a positive 96 and a positive 4. Let's put those together. So I get that my nth term equals -4 times n plus 100, because 96 and 4 make 100. Or another way to think about it, to find the value of my nth term, I multiply -4 by the term number, or the position number, and I add 100. So then I can use this formula. This is just the same formula that I had before, but it's specific to this situation, so it's simplified to this situation. And I can use that, let's say I wanted to find the 14th term. If I want to know when n equals 14, what my 14th term is, or what the value of that would be, so what I mean by that is the 14th number in this list, I can do a sub 14 equals -4 times 14 plus 100. So a sub 14 is going to be -4 times 14 is -40, and another, that's -56 plus 100. So a sub 14, or the 14th term, will be 44. Now I could have found the 14th term using this guy up here. No, I'm sorry. Using this guy up here if I'd wanted to. But because I had a simpler version, or a simplified version, it was easier to just plug in the 14 into this specific situation instead of having to do all the simplification and everything all over again. So this was a quick way for me to come up with the 14th term. It means if I kept listing numbers, I'd have 84, 80, 76, 72, da 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 da. My 14th number in this list would be 44. And that's how I'm going to use the formula for arithmetic sequences.